Dear students, welcome for the competitive session for the second PUC or the class 12 under the first organic chapter, that is called the HaloAlkanes and then the HaloArenes. So previously we have discussed the synopsis, means what are the various easily available points, or it may be the key points relative to the synthesis and then the preparation. Synthesis or preparation and then the properties relative to these organohalogen compounds, which can be of 5 different types usually: alkyl halides, alkenyl halides, alkynyl halides, aryl halides and then the R-alkyl halides. But preferably, as far the class 12 is concerned, we are much more concentrating on the which one? The alkyl halides called as haloalkanes and aryl halides, which are the aryl halides called as haloarenes. Okay. So now we will directly move on to the solving of some of the MCQs, multiple choice questions related to this, the first organic chapter of the class 12, or it may be the second PU. Okay. So let us start first. The first one, the first is isobutyl chloride is an a halide, dash halide containing dash secondary carbons. First we have to know what is the prefix that is here, iso. Iso means it is branch, no doubt. But it is not strictly the secondary. First, you have to remember that. Iso means first refers to what? CH3, CH3. Means if the carbon chain branching or the methyl group is at the second position, then we are calling that as iso. Butyl, what is butyl here? Totally 4 carbon atoms. Already iso means refers to 3 carbon atoms. Next, butyl means it is CH2 with chloride. Okay. Remember first, or we can solve this one. As if CH2Cl is already present, it is no doubt primary. If a CHX is present, secondary. If only CX means it is called tertiary. Means first it is open chain or closed chain. Here it is aliphatic first. Aliphatic with what? Primary. Aliphatic with primary means I can choose either A or it may be the D. In addition to that, containing dash number of secondary carbons. A carbon which is surrounded by 2 other is called secondary. This is primary carbon. This also primary carbon. This also the primary carbon. This is now the tertiary carbon. Which carbon it is? It is the tertiary carbon. But there is no presence of which one? Secondary carbons. Means first it is open chain, that is what is called aliphatic. Then as it is having a carbon in the form of CH2Cl, it is an example for a primary. But there is no presence of which one? Secondary carbons. Hence it is aliphatic, primary with 0 what atoms? Secondary carbons. Okay. So that is about the first one. Let's have the 2 here. Which of the following compounds can be used to prepare methane and ethane in a second step? Or methane or ethane by a one-step reaction. Means we can get both the methane and then the ethane in a single one. Okay. So here we have to get methane and we have to get ethane, CH3CH3 or C2H6. Among these, which can be obtained here? If I use CH3I for example, methyl iodide, is it possible to have this? This is haloalkane, this is alkane. How haloalkanes are converted to this? Just by the process called as reduction. Using lithium aluminum hydride or zinc in HCl or zinc amalgam in alcohol or sodium in alcohol. All these are the examples related to the which one? Reducing agents. Means we can have the conversion from methyl iodide to methane. Okay. Then how it is done? It's well known, named reaction. What is that called? When this haloalkane called methyl iodide made to react with sodium in presence of what ether? Dry ether. Means usually we are using the 2. If I take 1, I am getting the 2. If I take 2, I am getting the 4. It is indirectly the what reaction? It is called Woods reaction. Means from which one? Methyl iodide. I can get not only the methane, which is done by the process called as reduction using a suitable what agent? Reducing agent, but also the ethane by the well-known named reaction called as Woods reaction. Therefore, which is the possibility here or what is the possibility here? Methyl iodide. Okay. So let's move on to the third here. In the presence of peroxide, HCl and H do not give anti-Markovnikov's addition to alkenes. Because why? So usually anti-Markovnikov's rule is applicable. AMR. First, what is MR? Negative to the less number of or negative to the carbon containing less number of what atoms? Hydrogen atoms. That's the Markovnikov rule. What is anti-Markovnikov rule? The negative part to the carbon with more number of hydrogens if and only if it is HBr in presence of peroxide acting as a catalyst. It's called as peroxide effect, called as Courage effect, or it is also called anti-Markovnikov rule. But here, this is not applicable in case of either the HCl or it may be the which one? HI. Because if I study the mechanism of that one, here both the reactions are, both steps are exothermic. In case of what? HBr using the peroxide, both steps are found to be what in nature? Exothermic. But if I carry out the same thing with either HCl or it may be the which one? HI. One step is exothermic and the other step is endothermic. Usually we know that exothermic substances are the compounds or the reactions are found to be the better stable compared to that of the endothermic. As we are getting one of the step is found to be the exothermic or one of the step is found to be the endothermic, then we can decide there is no possibility with respect to either HCl or it may be the which one? HI. Therefore, the option is both are highly ionic. No, that is not the possibility here. One is oxidizing and another is reducing. No, all are reducing here. One of the steps is found to be exothermic in both the cases. Meaning in case of HCl and HI, one of the cases is found to be the what? Exothermic. All steps are exothermic in both the cases. Means all steps are no doubt exothermic if it is only the HBr. Suppose if it is HCl or HI, one step is found to be the what thermic? Exothermic. That is why we can opt that in the form of 3 as C. Okay. So let's move on to the fourth here. Cl, CH2, 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 Cl in presence of sodium ether. It is called as 1,3-dichloropropane. This reaction is known as Woods reaction, Fittig reaction, Fred's reaction or Woods-Fittig reaction. So here, when two molecules of Rx made to react with two molecules of sodium or two atoms of sodium in presence of dry ether, we are getting this and this. This is a well-known what reaction? Woods reaction. But here, it is not a haloalkane, it is a dihaloalkanes. What type of it is? Cl, CH2, Cl, CH2, 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 Cl. That is what we have written. 1,3-dichloropropane it is. 1,3-dichloropropane. When it made to react with what? Sodium in presence of what ether? Dry ether. Again, there is no doubt the removal of what? NaCl. But the thing is, I am getting CH2, CH2, CH2. These two are linked by this one, or we can mention the form of triangle here. What is this called? Cyclopropene. This is called actually intramolecular Woods reaction. Here, the reaction is taking place between two molecules of haloalkanes. But here, in case of this one, the reaction is taking place within the same molecule. What is the same molecule here? It is strictly the terminal dihaloalkanes. What alkanes here? Terminal dihaloalkanes undergo not the Woods reaction, but it is called as intramolecular Woods reaction, or it is given by another name called as Fred's reaction. Intramolecular Woods reaction is also called as what reaction? Fred's reaction. Another thing is, suppose instead of this, if I use a zinc, instead of what? Sodium, if I use this one, here also the thing is, instead of this I am getting ZnX2. The product is higher alkane, but the name of this reaction is called as Frankland's reaction. Sodium with haloalkane, higher alkane is called as Woods reaction. Terminal dihaloalkanes with sodium in dry ether gives rise to cycloalkanes is called as intramolecular Woods reaction, called as Fred's reaction. Suppose instead of sodium, if I use a what? Zinc. The product is same, but the reaction name is given by what? Fred's reaction. As it is a cyclopropane. The thing is, here we have to mention like this. What is this? Dry ether, sodium in presence of dry ether to form what propane? Cyclopropane. What the propane it is? Cyclopropane is called as intramolecular Woods reaction, which is also called by another name, that is called Fred's reaction. Okay, so that's about the fourth. Next we will move on to the fifth one here. An organohalogen compound which can take part in both the which and a which addition as well as then also the nucleophilic substitution reaction or nucleophilic reaction is. So usually what we have preferred is unsaturated compounds undergo addition reaction, whereas saturated compounds undergo substitution reaction. First, the general thing. There are some exceptions here, but the thing is, in general, unsaturated compounds readily undergo addition reactions, whereas the saturated compounds undergo what? Substitution reaction. So here, an organic compound which can have both the which addition as well as this one. So let us take this ethyl bromide. Vinyl means what? CH2 double bond CH single bond Cl. Allyl means what? CH2 double bond CH single bond CH2 single bond Cl. Then secondary propyl. Secondary propyl is also called as isopropyl in the form of which one? Chloride. This is strictly saturated, unsaturated, saturated, unsaturated. This is saturated. Means I am deleting this and this. Why? They undergo only the what reaction? Substitution reaction. What reaction here it is? Substitution reaction. But what about these two? These two, no doubt they undergo what reaction? Addition reaction. Apart from that, here we are having only C double bond C, but there is no C single bond C here. So due to this, it is unsaturated. Means it undergo what reaction? Addition reaction. But what this carbon atom is? Saturated carbon. As it is a saturated carbon atom, means it undergo what reaction? Substitution reaction. Therefore, both possibilities are possible in case of which chloride? Allyl chloride. Means with respect to carbon-carbon double bond, it undergo addition reaction, whereas the presence of a saturated or the sp3 hybridized carbon makes the compound to undergo what reaction? Substitution reaction. Okay, so that is fifth C. Let's move on to the sixth here. The final product formed when alkyl halide reacts with ammonia is primary amines, secondary amines, tertiary amines, and then the quaternary ammonium salt. It's a very important chemical test to distinguish between whether it is a primary amine or a secondary amine or a tertiary amine in case of the amine chapters. Primary amines can form QAs. What is QAs? Quaternary ammonium salt. Secondary amines also undergo this. Tertiary amines also undergo this. Means all form the final product as what? Quaternary ammonium salt. Means as if he has mentioned the what product? Final product. Means primary, first haloalkanes are converted into respective primary amines. Primary amines are converted into secondary amines. Secondary amines are further converted into tertiary amines, and tertiary amines are further converted into what? The quaternary ammonium salt. Let us have that particular reaction right now. RX NH3 minus HX means it is the nucleophilic substitution reaction. It is the nucleophile here, NH2 minus RNH2. It is called as what amine? Primary amine. This further reacted with another molecule of RX minus HX to form RNHR, secondary amine. This further reacted with another molecule of RX, minus HX to form RNRRR. This is called as tertiary amine. Reaction doesn't stop here. Why? Because there is a presence of one lone pair of electrons in this. And this attacks now. Directly I will write this as like this. This is called as QAS. What is QAS? Quaternary ammonium salt. Means when haloalkanes meet to react with excess of haloalkanes, or when it is a final product is obtained, means it is only the quaternary ammonium. Suppose if it is 1 mole, it has primary amine. If it is 2 moles, secondary amines. If it is 3 moles, means it is called as tertiary amines. If it is 4 moles from the starting RX, means it is found to be the which one? Quaternary ammonium salt. That is 6th is found to be the what? D. QAS. The name of this one is also called as, instead of this we can write that as tetraalkyl ammonium halide. Tetraalkyl which one? Ammonium halide, which is an example for a what? QAS. What is that QAS called? Quaternary ammonium salt. Okay. So that is about the 6th here. Next we will move to the 7th here. For the following halides, halodions, Cl minus, Br minus and I minus, the increasing order of nucleophilicity is, would be. What is the order here? General concept is, lesser the electronegativity, more is the nucleophilicity. Nucleus loving means it should have the what? Positive charge loving. If it is having a positive charge loving means it should be more rich with the electronegativity. Here, lesser the electronegativity, more the electronegativity means what? Means it always withdraw its electron towards itself. That is why the net electron density on this one is going to be less. Means it is less towards the what? Attracting for the nucleus. Means lesser the electronegativity of that particular element, more is the what city? Nucleophilicity. Means what is the order here? Which is the most electronegativity here? Fluoride first, then followed by chloride, bromide and then the iodide. Means F minus is greater than, Cl minus is greater than, Br minus is greater than, I minus. What this order is? But how it is there? Inverse. If this be the case, can I say that F less than, Cl less than, Br less than, I less than, I minus less than. Therefore, which is having the highest electronegativity, sorry, nucleophilicity, which is having the least electronegativity. Which is the least electronegativity here? It is I. I greater than, Br greater than, Cl greater than and F. So among this, I think there is no fluorine here, of course. In this one, we are having that. I, Cl less than, Br less than, Br. Okay. So that is lesser the electronegativity of that, more is the what city? Electrophilicity. Let's move on to the 8th now. In presence of which one? Anhydrous aluminum chloride, benzene and N-butyl bromide react to form what? So here one thing you should be very clear first. When benzene, I don't want to write the structure for that. MEX, ETX, PRX, BUX. Here the product is BME. Here the product is BET. Here the product is, this is called methyl halide. The product is called as methyl benzene. Here it is ethyl benzene. So here we are having two. Whether it is NR iso, which is also called as secondary. Here NR iso R, secondary R, tertiary. Means how many types of butyls are there? 4. Okay. So we know that it is the example for a what? ESR, electrophilic substitution reaction. Means the electrophile is what? R plus. What is that R plus here? Alkyl radical. That is what is called free radical alkylation. Methyl means methyl, ethyl means ethyl. Propyl means we are having a 2. What is that? N-propyl carbocation and then the isopropyl, which is the more stable. The stability of C plus is the order tertiary greater than, secondary greater than what? 9. Means if I take propyl, either it may be the N-propyl or it may be the isopropyl, the product is only benzene substituted with iso R, secondary propyl. Means Iso or secondary propyl, which one? Benzene. Then what must be the product here? If I use N, if I use iso, if I use secondary, if I use this one, the more stable is only the tertiary. That is why B is substituted with the tertiary butyl. Why? Means it undergo rearrangement. Usually this is done by the H minus shift, or it may be the CH3 minus shift, where the less stable C plus is converted to more stable, which one? Carbocation. You have to directly remember that. Suppose if it is any butyl, because as if he has taken benzene with N-butyl. In general, what we are asking, measuring, the benzene made to react with alkyl halide to form alkyl benzene. But it is not only the alkyl, it depends upon the stability of the carbocation that has been present. If I take N-butyl, if I take isobutyl or secondary butyl or tertiary butyl, the product is only which one? The tertiary butyl benzene. Okay? So that is about the question number 8, MCQ 8. Let's move on to the 9th here. Hunst-Sticker reaction is nothing but suitable for the preparation of what? What is that Hunst-Sticker reaction? It's the name reaction. When RCOOAG means it is called silver carboxylate or silver fatty acid, made to react with directly the bromine. There is a removal of AgBr first. AG with Br. Then the removal of carbon dioxide also, the byproducts. But the main thing is R substituted with this means it is called as RBr. It is called as bromoalkanes. Means when silver salt of fatty acid made to react with bromine, we are getting the which one? The bromoalkanes called as alkyl bromides. That is called as Hunst-Sticker reaction. 9C. Let's move to 10th here. Ethyl alcohol made to react with our ethyl iodide reacts with AgNO2, silver nitride, to give what? So you should be very familiar first. RH plus KCN AgCN, KNO2 and then AgNO2. These two are very important here because as if they are considered to be the ambidentate nucleophiles. They are called as ambidentate. So here the product is respective cyanides is formed, here respective isocyanides is formed. But here it gets CN means here it is CN. Here CN refers to what? NC in case of Ag. But it is reversed in case of this. KNO2 means it is RONO, but here it is RNO. This is called nitroalkanes. This is called as alkyl nitrite. Alkyl? So don't make a confusion regarding to the KCN, NAGCN and with the KNO2 and then AgN. Okay. So here the product is a nitroalkane as it is taking the ethyl. R is equal to C to H5. Here also it is C to H5. Means it is called as a nitro. Which one? Okay. Suppose if I use KNO2, potassium nitrate, I am getting the ethyl nitrate. But here it is AgNO2 means it is called as a nitro what? Ethane. Okay. So that is about the 10th here. Let's have the 11th here. The reactivity of the halogen atom is minimum in first, where the reactivity of that particular halogen is going to be minimum. So first you have to be very familiar. Ri is greater than Rbr is greater than RCl is greater than Rf. All iodoalkanes are more reactive compared to that of bromo, chloro and then the fluoro. Why? Because less electronegative. Less electronegativity means it is the weak bond. Weak bond means more is the reactivity. Here, as if I already mentioned, which is having the nucleophilicity order I minus, because of less electronegativity is going to be the what? More. Nucleophilicity means lesser the electronegativity, more is the nucleophilicity. That is why we can have the fast reaction in case of iodide. Similarly, it also depends upon the stability. What's that? Stability of carbocation. Because as if nucleophile is moved means we are getting R plus. R plus means it is carbocation. Carbocation order stability is what? Tertiary greater than, secondary greater than which one? Primary. Therefore, combining these two, we will have this. Minimum means whether it is, here it is propyl is primary, iso means it is called as secondary. Isopropyl and isopropyl means it is secondary. Okay, as it is having the minimum reactivity means among primary and secondary, which is least reactive here. So first I will delete this, least reactive means I am deleting this C and D. Why? Secondaries are more reactive compared to the top primary, means we have to choose the minimum, means it is primary. Among primary we are having the, where it is iodide or chloride. Iodine is more reactive than that of chloride, means the least reactive is going to be the what? Therefore it is called propyl, which one? Chloride. 11b. Let's move on to the 12th here. The CMG bond in case of CH3MgI is what? RMgX, called as Grignard reagent, alkyl magnesium halide. Halogen is minus, this is 2 plus, magnesium is bivalent. Means this bond is purely what? Ionic. What's the sum of the charges here? Plus 2 minus 1, here it is going to be the plus 1, I think. But here, this with this is going to be the delta plus. Therefore, this is delta minus. Therefore, it is going to be the what? Polar. That too with preferably the polar with what? Not ionic. Here it is the covalent nature. But here he has the bond between what? C, for example, here. C with Mg refers to the which one? Polar covalent bond, or in general it is called as the covalent bond. Okay? And also you have to remember the carbon is existed in the form of which one? Not the carbocation, but it is going to be the carbene ion. Here we are having the C is considered to be the, our alkyl group is existed in the form of carbene ion, whereas the Mg with the X is having the ionic bond, whereas the carbon with Mg is going to be the what? Covalent in nature. Okay? Let's have the 13 now. Which of the following is having the highest nucleophilicity? Highest nucleophilicity. Highest nucleophilicity means lesser is the electronegativity. Lesser is the what? Electronegativity. Among that, what I observed? F is greater than, I think, among that, O is greater than, N is greater than carbon. Okay, this is what order? Electronegativity order. The electronegativity here. But he has the nucleophilicity. Therefore, what is the nucleophilicity order? F is less than, O is less than, N is less than C. C in the form of NH3 minus, this in the form of NH2 minus, this in the form of OH minus, and this in the form of this. Therefore, the highest nucleophilicity refers to the least electronegativity, and that least electronegativity is observed in case of methyl carbene ion. Methyl carbene ion. That is 13C. Let's have the 14 now. The alkyl halides that can be made by free radical halogenation of alkenes are free radical halogenation. I think you had studied in detail about the mechanism, that is chain initiation, chain propagation, and finally the chain termination step. RH, for example. What's that? RH. This made to react with, for example, halogens. RX means here it is RF plus HX, RCl plus HX, RBr plus HX, and RI plus HX, HF, HCl, HBr, and then HI. Influence of H nu. So what is H nu? Means sunlight, done by free radical mechanism. This is possible. This is possible, but not RF, but not RI. Why? Because this fluorine being the most electronegative, it leads to the explosion. That is why the fluorine, direct fluorination is not possible here. Next, apart from that, Iodine, we know that it is found to be the least electronegativity, is found to be the very slower, and also it is found to be the what? Reversible in nature. What in nature? Reversible. Means the product formed again converted back into this. That is why we are adding the oxidizing agent like HNO3, or it may be the HI. Means for the iodination to carry out, we have to use only the oxidizing agent apart from the sunlight. Means fluorine being highly electronegativity, it leads to the explosion, therefore the fluorination of alkanes is not possible. Iodine being the very least electronegativity, the reaction is very, very slow such that it becomes reversible in nature. To enhance that, what we are using? The oxidizing agent. Means on normal temperature, it is possible in case of the chloro and then the bromo, but not either the RF or it may be the RI. Therefore, it is found to be the E. Hence it is 14A. Next we will move to the 15th, I think. Of the following halides or alkyl halides, one with the lowest BPs. Lowest which one? BPs. BPs depends upon the hydrogen bonding and then the dipole-dipole interaction, or it may be the weak van der Waals interaction. There are three different possibilities. Here haloalkanes means you are having the what? Polarity. More the size of R group, more is the BP. First you have to remember, because more is the van der Waals interactions. Increase in branching of R, it is strictly for isomeric RX, means haloalkanes. Lesser is the what? That you have to remember first. Means for a given series, whatever it may be the series here, organic series or organic family or organic functional group series, as the size of the alkyl group increases, the van der Waals force goes on increasing. As the van der Waals force increases, the boiling point also goes on increasing. But suppose if they are found to be the isomers having the same formula, molecular formula, as there is an increase in the branching, means increasing branching decreases the van der Waals force. A decrease the van der Waals force means it decreases the what point? Boiling point. So here he has asked the lowest. Here it is ethyl, here it is propyl, here it is butyl, here it is methyl. Lowest means smaller alkyl group. Which is a smaller alkyl group here? It is going to be the least. This is having the least BP. Least BP. Then which is having the highest BP here? Here it is ethyl, here it is propyl, here it is butyl. Means this is having the highest BP. Okay? So therefore, one with the lowest BP is found to be just only the what? CH3Br called as methyl bromide. Okay? That is about the 15 in the form of D. Let's have the 16th here. When benzyl chloride is heated with sodium metal in dry ether, the end product or the product formed is what? What chloride it is? Benzyl chloride. When two molecules of which one? Benzyl chloride made to react with sodium in presence of what ether? Dry ether. Benzene or the phenyl group here with attached to the CH2. Again, as if we are taking the, CH2, benzyl, it is not chlorobenzene, it is benzyl. Benzyl means it is CH2Cl. CH2 single bond CH2 with what? This is called as bibenzyl. Whether it is Woods or Woods-Fittig or Fittig reaction. If both are alkyl, it is Woods. If both are aryl group, it is called as Fittig reaction. If one is alkyl and one is aryl, means it is called as Woods-Fittig reaction. But what it is? This R-alkyl group always undergo what reaction? Woods reaction. Even though it is aromatic halides, but it is not aryl, means the halogen is not directly attached to the benzene nucleus, but it is attached to the what? The side chain. That is why, as it is R-alkyl or alkyl, always undergo what reaction? The Woods reaction. Means the formation of a bibenzyl from benzyl chloride with sodium with a dry ether is an example for a what reaction? Woods reaction. Therefore, it is found to be the B. 16B. Let's have the 17 now. When ethyl bromide is boiled with silver oxide suspended in water, it gets converted into what? Whether it is ethanol or ethylene oxide or diethyl ether, or it may be the ethylene. RX made to react with Ag2O, dry silver oxide. What oxide it is? Dry silver oxide. So here 2Ag, 2Ag means 2AgX has been removed. Here what is left? ROR, it is called as ether. When it is suspended in dry ether. When the same RX made to react with AgOH, it is indirectly called as moist silver oxide. Because when Ag2O made to react with H2O means it forms AgOH. AgOH is called as moist silver oxide. As it getting plus and minus here. It is similar to that of either KOH or it may be the NaOH, aqueous. What happens when this made to react with haloalkanes made to react with this? It undergo NSR to form OH. It is called as alcohols. It is called as alcohol. Means when haloalkane made to react with dry silver oxide, they form respective ether, whereas the same when it is suspended in water called as moist silver oxide, they form respective which one? Alcohols. Here it is silver oxide suspended in water, means whether it is ether or alcohol, here it is alcohol. Which is that alcohol? Ethyl group is there, means it is called as ethanol. And it is 17A. Okay. So let's move to this 18 now. 2-bromopentane with alcoholic KOH give or gives what? Where it is pentene, cis and trans 2-pentene, but a trans 2-pentene is in major yield. Cis and trans pent 2-ene, but is isomer in major yield, but its isomer is in major yield. Pentene, cis and trans 2-pentene, but a trans 2-pentene is found to be the major yield. It's indirectly the application of Setzef rule. What's that rule here? Setzef rule. Which bromopentane here? 2-bromopentane. CH3, CH2, CH2, CH2Br. What is this called? 2-bromo what? Pentane. When this made to react with alcoholic KOH, the function of alcoholic KOH, just now I mentioned, if it is aqueous KOH, they form respective alcohols. But as if it is alcoholic, means it undergoes DHH. What is DHH? Removal of hydrogen and halogen. That is called dehydrohalogenation. First we have to remove this. There are two possibilities here. Whether you have to remove this hydrogen from this carbon atom or from this carbon atom. Suppose if this be the case, I am getting CH3, CH2, CH double bond, CH single bond, CH3. Suppose if it is from this compound, CH3, CH2, CH2, CH double bond, CH2. This is called as 1-pentene. This is called as 2-pentene. Means I am getting this. No doubt, this is major. According to what? Setzef rule. What rule it is? Setzef rule. I am getting the what? No doubt. 1-pentene and 2-pentene, but 2-pentene is found to be the more. Now, this is carbon-carbon double bond which is attached to the two different groups. Therefore, I can expect either in the form of cis or it may be the trans. If it is 2-pentane, I am expecting what is that? Either it may be the cis or trans. Usually we have mentioned trans are relatively more stable compared to the top this, because as if the trans means they are in opposite. If the two similar groups are on the opposite, means the what is that called as the collision between the opposite is going to be less. But as if it is cis, means both are on the same side, the collision means lead to the lesser stability. Therefore, what is the option here? I am getting 1-pentene, 2-pentene. Among 2-pentene, we are having the cis and the trans. And among the cis and the trans, which is going to be the more stable here, it is the D. D is what? First pentene called as 1-pentene. Cis and the trans pent 2-ene, but trans pent 2-ene is in the found to be the what yield? Major yield. Okay. 18, I think D. 18 D. Next, which can exclusively undergo substitution by SN1 mechanism. SN1 mechanism. One thing you must be very clear regarding this. SN1 is tertiary greater than secondary greater than primary first, whereas SN2 is primary greater than secondary greater than which one? Tertiary. Means this is the major first with respect to this, and this is the major with respect to this. But what is this here? Exclusively by SN1 mechanism. SN1 means it is found to be the tertiary. Which is the tertiary here? So I am deleting first. This is deleted. Why? Because it is aryl. Means aryl doesn't have the mechanism of substitution. Means it doesn't undergo NSR. But here it is primary. Therefore this is not possible. So this is secondary and this is primary. According to this, what we are preferring, isopropyl chloride we can expect. But here, this is more correct answer. Why? Because if I remove this Cl minus, it is called as benzyl CC. What is CC? Carbocation. Benzyl carbocation is more stable even though it is called as primary, because the resonance stabilization is better compared to that of the inductive effect stabilization. Therefore, even though isopropyl chloride is an example for a what? Secondary, it doesn't easily undergo which one? SN. But even though benzyl chloride is a primary alkyl halide, because the formation of the benzyl carbocation it is better stabilized due to the what effect? Resonance effect. That is why it is found to be the D. Means which can exclusively undergo substitution by SN1 mechanism is found to be the what? Benzyl chloride. One exception is there. Even though it is primary, our alkyl halides are found to be the more towards SN1. Okay. So that is 19D, I think. Next is the main product of the reaction of neopentyl bromide with aqueous KOH gives what? In general, what we have decided, when any haloalkane made to react with respect to aqueous KOH, RX plus aqueous KOH, it undergo NSR to form respective which one? Alcohols. As it is aqueous KOH means there is a alcohol here. Neopentyl bromide. What is that neopentyl bromide here? Neo means like this. A carbon surrounded by 4 is called as neo. Plus minus means first there is a mole of what? X minus to form carbocation. Then that carbon atom is attacked by what? OH minus like this to form respective alcohols, and that is called as NSR. NSR means nucleophilic substitution reaction. Now, when I remove this Br minus, I am getting the carbocation as like this. What is that? Like this. This is primary CC. What is primary CC? Primary carbocation. Carbon is surrounded by only one is called as primary. But according to we know that what is the stability order? Tertiary carbocations are better stabilized compared to that of secondary, followed by what? This. That is why I already mentioned in the previous, the stability of carbon cation, carbocation is done by either the H minus shift called as hydride shift or methyl minus shift, that CH3 minus shift. Here, due to the 1, 2 CH3 minus shift, which is shifting here, CH3 minus has been shifting here, such that it becomes CH3, CH3. As it loses CH3 plus means it is C plus. CH2 plus is attacked by this. Can I say that is a tertiary CC? It is going to be the most stable. Means we are converting what? The less stable carbocation into a more stable carbocation by the CH3 minus shift. Now there is an attachment of what? OH minus. Direct attachment of this. What's the product here? 1, 2, 3, 4 bute. Bute with alcohol at second position, methyl at second position. Therefore it is called 2-methyl 2-butanol. 2-methyl 2-butanol. Suppose according to the general concept, if haloalkane made to react with aqueous KOH means they form a respective alcohol. Suppose if it is neopentyl bromide means we are usually expecting it is neopentyl alcohol. No, it is not. First, you have to frame which one? Carbocation. And you have to observe the possibility here, whether that carbocation is primary or secondary or tertiary. If it is tertiary, no doubt it is. Directly we can put the nucleophile. Suppose if it is primary or secondary, there is a chance of converting from primary to secondary or secondary to tertiary, either by the H minus shift or it may be the CH3 minus shift, where the stability of the carbocation gets enhanced or increased. After that, there is a direct attachment of a what? Nucleophile. So here, it is not the neopentyl alcohol directly, it is over the 2-methyl-2-butanol. Okay, that is about the 20B. Next one is HaloAlkanes are prepared by refluxing alcohols with Ki and. It's the preparation. Okay, that's it. ROH. What is that ROH here? Alcohols. If it is this HCl gas in presence of anhydrous aluminum chloride, sorry, zinc chloride, RCl plus H2, it's a direct reaction. It is called as Gru's method. It's called as Gru's method, and this reagent is called as Lucas reagent. It's called as Lucas reagent. Suppose if it is HBr, we are getting RBr plus H2O. Suppose if it is HI, we are getting Ri plus H2O. As if there is no HF beads, because they can form a hydrogen bonding, therefore there is no preparation of which one? The fluoroalkanes. We have either the chloro or the bromo or the haloalkanes. But this is not readily available. How it is obtained? By treating either NaBr or KBr with concentrated sulfuric acid. The combination of potassium bromide or sodium bromide with what? Concentrated sulfuric acid will provide the HBr. Then similarly, this also not readily available. That is why what they will do, instead of that they are taking sodium iodide or potassium iodide with phosphoric acid, usually 85% of phosphoric acid. Means there is no readily availability of either the HBr or which one? HI. That is why the preparation of what they have asked here, HaloAlkanes is preferred by HI, but how that HI is obtained? By treating potassium iodide with 85% of which one? Phosphoric acid. That is 21D. Let's move to the 22 here. Identify C in the following sequence reaction. The first is ethyl alcohol reacted with SOCl2 called sulfonyl chloride in presence of pyridine to form A on treating with the KCN gives rise to B on treating with which one? The hydrolysis in presence of an acid gives rise to what? It's a direct reactions here. They are indirectly the preparations and properties with respect to HaloAlkanes. Let's have first, what is that? C2H5OH in presence of SOCl2 in presence of pyridine. Direct removal of this such that it forms C2H5 what? Cl. This is called as ethyl chloride. This made to react with what? KCl. Direct. What happens when HaloAlkanes reacts with this to form C2H5? NC or CN? CN. This is I think B. This 2H2O bar H plus means it is called acid hydrolysis. Acid hydrolysis of cyanides gives respective carboxylic acid. Hydrolysis of cyanide gives respective what acids? Carboxylic acids. Therefore, this is found to be the C called as propionic acid, or IUPAC means propanoic acid. So I think he has asked the C, I think. C is found to be the C2H5. The first is ethyl alcohol, this reactivity. So this is called as a Darjan's method, the well-known named reaction. What is that called? Darjan's method or procedure to form ethyl chloride. Ethyl chloride on treating with KCN to form respective cyanide called as ethyl cyanide on hydrolysis gives rise to propionic acid. That is about the 22 in the form of C. Let's move to the 23 here. The antiseptic, that is called as which one? The antiseptic character of which one? Iodoform. Iodoform is due to its, why it is found to be the antiseptic in nature? That is, I think you have heard about the tincture of iodine from the iodoform, CHI3. This is called iodoform. Why it is having the antiseptic nature, whether it is due to the poisonous nature or the unpleasant nature, liberation of the free iodine and none of the above. So here, it can have the possibility of forming this, that is the free iodine. That free iodine is helpful for the what nature? The antiseptic nature. That is used in the form of tincture of iodine we are calling. Means iodoform is helpful for the liberation of, first involved in the liberation of free iodine, and that iodine or the free iodine is helpful for the what nature? Antiseptic nature. That is about the 23 in the form of C. Let's have the 24th here. Which of the following compound reacts with chlorobenzene to form DDT? A best example for a what? Insecticide. How it is obtained? From chlorobenzene. When two molecules of what benzene? Chlorobenzene. What benzene? Chlorobenzene. This made to react with what? Acetaldehyde, nitrobenzene, M-chlorobenzene, and then tri. This one is called as trichloroacetaldehyde, or I can put in the form of 2 times of Cl, H here it is. CCl3CHO, this is called as chlorol. Chlorol is also called as a trichloroacetaldehyde. What is that called? Trichloroacetaldehyde. In presence of a dehydrating agent, what is that called? Concentrated sulfuric acid. Concentrated sulfuric acid. So what there is a possibility here? So here it forms. It is an example for a dehydrating agent, as if we are taking the 2 molecules of this. Therefore, we can have one chlorobenzene molecule here, another chlorobenzene molecule here. Here, as if we are having the 2 H here, H with O is removed, H with O is removed. Then, if I combine those two, what happens? It becomes CH with CCl plus the removal of which one? H2. This is called a DDT. What is DDT? PP dash. Why it is called PP dash? They are in the para position. Therefore, it is called as PP dash. Dichloro, diphenyl, trichloro, ethane, which is abbreviated as what? DDT, an example for a what? Insecticide. That is, when chlorobenzene made to react with chlorol, chlorol is also called as trichloroacetaldehyde. In presence of a constant sulfuric acid, it undergoes dehydration to form what? Para dash dichloro, diphenyl, trichloro, which one? Ethane, which is abbreviated as DDT. Okay, so that is about the numerical number, which one? 24th. Okay, so I think we'll stop at this in the first session. Okay, the continuation of this we will move into the second session of this haloalkanes and then the haloarenes. Okay, so we'll continue in the next session. Thank you very much.